I am going to tell you how to find and remove duplicate and similar images in your dataset with Python, and we are starting coding right now. Hello, my name is Paweł Rolbiecki from AIexperiments.com. If this is your first time here and you want to learn how to experiment with artificial intelligence, be sure to subscribe and click this little bell so you won't miss anything important about artificial intelligence next time. And today we are going to deal with a problem which came up last time when I was cleaning the dataset with MobileNet SSD, detector and OpenCV. It turned out that data which were produced by MobileNet SSD are duplicate and really similar to each other. Today we are going to clean it. You may ask yourself, should I really have to write my own Python code? In my opinion, definitely yes. I don't want to use external software, I don't want to think about licenses. As you have probably seen on my GitHub account, which is linked down below, there is a file called AI animals prepare crop, and we are going to deal with it now. Alright, Python is loaded, but before we start coding, I just want to show you that we are going to simplify our process as much as possible. I'm just reducing the amount of classes to 2 bird species. Let's start with importing all essential libraries that are used in this script. And my idea is to first of all convert all the data in my directory, which you can see here, into black and white images. So I need a function which will handle this process. All right. So this script now will produce 32 by 32 black and white, grayscaled images, and we are going to start it right now. Boom. Yeah, it's producing. You can see that those files are appearing here. And yeah, finally it's done. Yes, you can see it. So we are having grayscaled images of those 2 classes, and we can now start comparing them and counting the root mean square, because my idea is to count the root mean square between every single image and decide if they are duplicates. Now let's find all duplicates in the grayscaled images, and I have prepared just a little function and of course some code iterators here that is iterating over the class path, and it's taking the detected directory, and then also it creates the it takes the grayscaled images directory. Those 2 parameters are being passed to the find and delete duplicate grayscale images. We don't need to make again grayscale images, so we are just forgetting about them, or almost forgetting about them, because we need this data path here. All right, so what's going on in this function? I am taking the base image, it's called the compare image name, and this image is taken from the black and white directory, and I am again taking a searched image. The searched image is taken from the downloads directory, and the idea is to just have a name of this searched image. Then I'm checking if those names are equal. If they are equal, of course I don't want to delete the file itself. If they are not equal, I am opening these 2 files, so the searched image and compare image, and I'm counting the root mean square between those 2 images and deciding if the root mean square is lower than 3, I'm removing this file. Why 3? I have made a little experiment. It turns out if the RMS is lower than 3, then we are having similar, and if the RMS is almost 0, we are having almost the same images. So yeah, let's check how is it behaving. Okay, it's going on something here. Yeah, it found classes that are, it found images that are nearly the same, and it deleted those images. It deleted the 435 PNG file. Oh, sorry, it was looking for this file and deleted those files which are decided by him as duplicates. Alright, this script finished working. You can see that the process is finished with the exit code 0. And let's check it out if this directory has been removed. Yeah, we have 601 file. Error. Okay, never mind. Close this. No such file directory. Just wait a second. And properties of this file, you have 619 files. So it seems that the script is working and we get rid of the duplicated and similar images. Okay, it's time to the next step. Synchronization of those two directories to be sure that in the detected directory we are not having duplicates and similar images. For example, like this. What's this? I don't really know. This is also a duplicate. Yeah, so definitely we need the synchronization right now. Okay. Let's start with synchronization. Our detected and grayscaled images. We need a find_del final function, which takes the detected directory and grayscale directory. I am listing all files in grayscaled directory as a list, and iterating over detected directory, I take the file and I check if this file is on the black and white list. If not, it's the moment I have to delete it, and it's the moment of synchronization between those two directories. Okay, let's check how it is performing. I don't need the section. Let's play. Yeah, the algorithm was pretty fast, and I should have the quantity of my files in our catalog pointed to 601. Okay, it's 601. So it seems that this script is working and synchronizing both directories. All right, it's probably the end of the script. If you would like to take it originally, you can download it from my GitHub account. It's available on MIT license, and feel free to use it and change. What is the real reason to get rid of duplicated similar data? In my opinion, while training your deep neural network, you have to have your data set as consistent as possible without duplicate images or even similar. The reason is that the network is learning patterns that are occurring too often, and it will not be possible to get high accuracy in distinguishing between two classes of birds in this case. All seems that we are getting to the end of today's tutorial. If you like this video, push this like you are pushing your origin master to your GitHub account, and subscribe. It will really helps me. See you next time, because next time we are going to deal with the H5Py library in Python to pack all those data, all those images into 3 big containers to feed our neural network. And see you soon!